All right, so this will be our first lesson for Math 1, and we are going to start talking about functions. So we have this DVD vending machine here, and the first question we've been asked is if we push A1, what are we going to get? Well, A1, looking here, corresponds with Gone with the Breeze. Same thing if I hit the button C2. Well, C2 is right here, C2 is right here. So that would be Raiders of the Lost Ark. And then same with B3, that would be The Wizard of Oz, just based on where they are in the vending machine. Now, assuming that they didn't misplace any DVDs and that all the buttons are working properly, what would happen if I hit A1, C2, or B3 a second time? As long as it's functioning properly and it's been filled properly, I should get the same DVD. So this process of hitting a button and receiving something out of a vending machine actually leads us to some vocabulary for functions. So when we push a button, the buttons themselves are our inputs, and then we receive a DVD, so what we get is our output. So our next question, does every input have an output? Well, in this case, not every input has an output because this button B1 is sold out, so we would not receive anything if we hit B1. So no, B1 is sold out, so we do not have an output there. So when we're talking about functions and representations of functions, there's a few different ways that we can represent our inputs and our outputs and how they relate to each other. The first is called a mapping, and we're going to use arrows to tell what input gets mapped or associated with another output. And I went ahead and I drew this for you so you could see it. So on the left-hand side in that oval, we put our input values. And on the right-hand side for our outputs, we put our outputs. And then we connect our input with an arrow to the output that corresponds with it. And you'll notice here B1 does not have an arrow because it's sold out and we will not get an output there. So the next way that we could represent these inputs and outputs is an ordered pair. It's going to look like this. It's going to have those curly parentheses that are called braces on the outside, and then we write them as points, what it looks like points. We do parentheses and we separate the input and the output by a comma. We put our input first and our output second. Now, I did not write every single one because that would be a lot to write down, but I gave you an idea of what it would look like. Now, if this was a true ordered pair list, every single one would be listed. I would not list B1 because B1 does not have an output, but everything would be listed here. So you would have 8 ordered pairs in your list. So going on to our next representation, we could also do a table. So when we take a table, or when we're making a table, we take our ordered pairs or our inputs and outputs, and we list them either in a vertical two-way table or a horizontal two-way table. I didn't have much space in this document, so I did it horizontally with input always on the top, output always on the bottom. If it's a vertical two-way table, input is always on the left, output is always on the right. you'll notice that I did not list B1 in my table, and that's because B1 doesn't have an output. I wouldn't have anything to list there, so B1 does not get included. So if I was going to take this table and make a graph of this table, I'm going to have dots or points that represent each ordered pair. So along the horizontal axis, I would put the inputs. I would put the actual buttons that are listed. So that would be this way on my graph, and each tick mark would just be a button. And then vertically, we're going to have our outputs. So I would list my movies along the vertical axis. Each tick mark would be a different movie, and then each corresponding ordered pair would be a point. So this is going to lead us to actually talking about what a function is. So here you'll see a function is when each input is paired with only one output. So if I'm talking about the vending machine, does each input get paired with one output? And this actually ends up not being a function because B1 does not have an output. So that makes this vending machine scenario not a function. It is a relation because buttons and DVDs are related, but I cannot call it a function since B1 does not have an output here. So if I push C1 and Finding Dreamo and Raiders of the Lost Ark came out, would that be a function? Well, if I'm hitting one button and two different things are popping out of the machine, that's no longer a function because I'm getting two different DVDs hitting the same button. All right, next question. So now we're talking about an age machine. So if I select any age, the name of anyone that age is going to pop out. Well, if we took our school, for example, if I picked the age 15, there would be a variety of different names that we would receive by just selecting that one age. So that is not a function because I would get multiple names for the same age. If we did it in the opposite way, if the name was the input and the age was the output, then we would consider that a function. All right, so now let's look at some examples of functions and non-functions. We're going to start with non-functions, and we're going to look at how to tweak them to create a function. So the first one we're going to look at is a mapping. And you'll notice I've already circled here why this is not a function. April has two different arrows that are connecting it to two different statements in my output. So because of April, this is not a function. If I'm looking at this list of ordered pairs here, I'm looking at the input value only, which is the first number in an ordered pair or the first value in an ordered pair. Because I see 3 show up twice as inputs, this is not a function. Here in my table, you'll notice that -5 and +5 have both repeated in the output. That's okay. What's not okay is if I have a value in the input that's been repeated. Here 9 gets paired with -5, and here 9 gets paired with +5. That's not okay. I have two values for 9 that are matching with two different output values. That is not a function. And then for my graph, you'll notice I could draw a vertical line here, and there would be two different points for that one specific x value. Some people refer to this as the vertical line test. If I took a pen or a pencil and had this represent a vertical line, if at any point in time my function hits that pen or pencil more than one time, no longer a function. So those are examples of non-functions. Let's look at examples of functions. So I took the same pieces of information I had before for not a function, and I switched one thing to turn them into functions. So here April was the issue before. Instead of April going to rain and sun, now April only goes to rain. Each month here in my input only has one arrow connecting it to an output. That's good now. It is a function. Coming back to my list, so I had 2 3s here. I changed that second 3 to a 5. Now my inputs are 1, 3, 5, 7. We're all good. Now it is a function. For my table, again, I had 2 9s, so I took that second 9 that was repeated and I changed it to a 13. Now I have 5 distinct input values that are all different, and we're good. It is a function. And last but not least, I took a graph, and instead of having a circle, I stretched it out into this wave shape. And if I take my pen, you'll notice as I move along here, the function itself is only ever hitting my pen once, so that would be considered a function.